So in this section, we're going to look at the use of Python's equivalent of the setTimeout function. So setTimeout function that is in JavaScript that comes naturally with JavaScript. So setTimeout. There we go. And how does it work? So basically, JavaScript offers us this timeout function, which is quite convenient in a way that we can declare a function. So we can say function. Let's see if I can. We can declare a function like this, and our function could be something like, say, hello. And then it will take in some parameters, possibly, but in our particular case, we don't want any parameters to go in there. And inside of our block of code, we can do something like log to the console. Oops, I didn't mean to do that, I think. Control Z. Let's try that again. Log to the console, so this one over here. And inside that, we could do like hello world. Now, the usual way of running this function in JavaScript is we could just call a function. So we could do say hello, and I believe that if we run our code now, we just get the hello world, which is down there at the bottom. So if I highlight it over there, it just says hello world. That's what's done. But we want to put this function on some kind of timer to run at a later point in time, and out of the box JavaScript offers this. I'm going to zoom in a little bit so that it's clear. Control plus, there we go, so a little bit clearer. So we have this function that's called setTimeout, and it's set timeout, so just over here. And this function then, when we do the open brackets, we get the little definition of how it is, and one of the functions, this is all about callbacks in a way, really, this setTimeout, but basically it's the first thing is our callback function, and then the next bit is the number of seconds, the number of milliseconds, and kind of like here, because we've got the callback, and I just wonder if it says the number of milliseconds anywhere. Callback is delay. Yeah, and it says the delay in milliseconds afterwards. So we've got like a nice kind of like documentation on it. So the function that we want to call back in our case is say hello. So that's kind of like our callback function, and then the waiting time. So if we want to wait for 1 second, we will put in 1000 like this. So now if we run our code, we'll hit F5 a second time to run our code. We're going to get 2 hello worlds, and the first one is from the original hello world, and if you noticed at the bottom, I'll run it a second time just so you see, the second one waited 1 second and then printed out hello world. And in fact, let's make it wait 3 seconds just for the sake of it, and just effectively look down here where we're logging to the console. So just down at this this bottom section of the code down here, where when I press run, we see what happens. So F5 to run our code, we see that's begun to run. The first hello world prints, and then we wait for 3 seconds, and then the second hello world runs, and that's this is the callback function that gets called back. Now, what's interesting is you can create this asynchronous behavior. That's the whole point of, or not the whole point, but that's one of the things that this kind of like can be used to demonstrate it, because we can do all of these different functions, and we can give them we can create many different functions, and we can create lots of different like time delays. These time delays are in milliseconds. So and then we can make the run, and it'll run at all at their certain points in time, and then afterwards they'll kind of like spit back out their answer. So the question is does Python have the equivalent to that? So the first thing I did was, because I just saw this in the video, and it's kind of like, and I was actually looking at a video on callback functions rather than on setTimeout, but setTimeout is something that uses it, and I was like, that's quite interesting, because that's a good use case for where you might have a callback function. So does Python have a similar thing where you can do like some equivalent of this setTimeout, where you can run this function after a certain number of seconds? And so I actually stuck this thing into Google Bard. So, and in fact, what I'll do is I'm going to open up my new version. So I guess over here, this is Python, so our Python version. I've kind of like, let's do a clear of that, and we'll do, because I'm going to start running it all from the beginning. So the first thing I did was I thought, okay, I'll go and stick this into Google Bard somewhere, and actually part of the set timeout thing, like here it is in Google Bard as well. I was like, just get an example of how it works, just so that I could copy and paste it into the original code. And sorry, not Google Bard, Claude, which is the new AI thing that I've been starting to use for a while, and it gives you the worked example of it. And my example was pretty damn similar to that one anyway. But we go back and I asked a question. I think it was here. There we go. Python timeout function equivalent, right? So this is my question to Claude, which is Anthropic's AI, I think. So Claude AI, I'm just going to call it. And I have a whole conversation about this because I do. Does Python have the equivalent of the JavaScript set timeout function? And it says yes, Python has the equivalent of the set timeout function. The main way to implement the timeout function is to use a time.sleep. Right, and I take aversion to that because that's not going to be correct. It does actually mention later on the correct way, but we can do the import time module in Python, and then we can do something like time.sleep, and then we could sleep for say 5 seconds, and then we could do print hello world. Right, we could do something like this, and we could run our little piece of code. I'll run it, I guess, in interactive Python on the side because it's a little bit nicer. When it actually starts running, I guess we'll see it waiting. I should have put waiting before. Just connecting to the kernel at the moment, as you can see from the bottom. That's what it does when I do the interactive, as opposed to pressing F5 and running it in the terminal. And here we go, it's running its code, and it's waiting now for 5 seconds because this is this sleep.5, and then it prints this hello world. But the difference between the set timeout and the time.sleep here is a set timeout function in JavaScript is asynchronous, which means it can go and do a whole bunch of other operations. So in our JavaScript, wherever we had it, this set timeout thing here, we've got this say hello 300 here, but we could just do some more. We won't even do say hellos, but we'll just do some console logs actually. So let me just do this. I am doing work, right? And then we can paste the same thing in, and sort of like do I am doing more work, right? And when we run our piece of code again on our one, it's not going in the interactive terminal on the side, it's going down below, so it's going in the terminal below. If I hit the F5 button to run it, we'll see our first hello world that gets done instantaneously, because that's the first thing. Then it says I'm doing work, then it says I'm doing more work, and this set timeout, this waiting thing, it waits for 3 seconds. That's why it comes at the end. So effectively, it kind of like it gets initiated here. It starts like that's where it's actually declared and invokes itself, but it actually comes in and does its running of the code. It finds itself somewhere here effectively after 3 seconds, and we can do a tremendous amount of work in between those 3 seconds before this set timeout thing. So this set timeout function is asynchronous. We want this asynchronous behavior. Now our Pythonic version, when we are looking at this just time.sleep thing, is not going to be good enough because this is blocking. So if we wanted to do these other pieces of code, there would be no place to do it. It's literally going to block. So it's not a case that this sleep thing, this print hello world, or any function that we ran below, that it would do anything other than blocking. So this is always blocking. So time.sleep is blocking. So I just kind of like mentioned this. I will mention this later. But if I zoom into the Claude thing, so let me actually make this a bit bigger and Control+ on it so that everything is readable. If I can, yeah, it can be. Yeah, I'm allowed to do that. So we can see it here. The time.sleep function makes Python pause a program for a specified number of seconds. So it can be used to create a delay or timeout similar to the setTimeout function in JavaScript, but that's not true. And I'm actually looking to see if anywhere, if it does or doesn't mention the asynchronous nature. It does begin to mention it down here actually. So time.sleep is the simplest way to mention the blocking timeout in blocking Python code. And we don't want blocking. We want asynchronous, but there are also options for asynchronous timeout schedule and schedule callbacks using async.io threads or external libraries. The overall concept is very simple, similar to the JavaScript setTimeout. So let's just have a look at it, and it does actually mention it. So you can use the threading module, but it doesn't tell you how to use it, and you can use the async.io module, but it again doesn't tell you how to use it. Now, I put in but time.sleep is synchronous, whereas setTimeout is asynchronous. So now it gets a hint. So you're right, time.sleep blocks the execution of the program in Python, right, while waiting. So it's not asynchronous like JavaScript setTimeout. We want to achieve asynchronicity to get I made that word up. I don't know if asynchronicity is a word. We want to get create asynchronous code. To get asynchronous non-blocking behavior in Python, you would need to do something like async.io.sleep. Now, async.io is by far it has more control than threading. But I don't like async.io for one reason, which is for the most part, well, the reason I don't like it is that you have to do an async def function, and then you do an async.io run, and everything runs on the main loop, and then everything has to be asynchronous thereafter. So all functions that you kind of like use, everything has to sort of use this asynchronous way. But it does offer you this method, which is async.io.sleep. But if you want to do something a bit more simplistic, as in, and you don't mind, the advantage of async.io is I believe it avoids any race conditions, but these are very, very unlikely to occur. In fact, I've never occurred race conditions when I've used threading, but I suppose you could. There are cases, like there are edge cases where you could. And async.io, the module, gives the user the control to literally not just have asynchronous coding, but determine where things come in the event loop. Whereas this threading module, you kind of like put your hands into the or you put your trust in Python interpreter that it will thread at the right positions. But it basically always does thread at the right positions. I haven't really got a problem with it. And the nice part about it is that I can then just use my regular synchronous function, so I don't have to do an await async.io sleep here. I can do something else. So we have these methods. There's also another method here, which is an app scheduler, but I presume, I can test for this, that that's not a built-in module. I think we prefer built-in modules. So I go over here to our, which one is it? It'll be this one here, I guess, which is the time.sleep. That wasn't very good. We'll comment out this time.sleep. It didn't work the way that we wanted to. And then I will go back to, I guess, we'll look from app scheduler. Let's just see if it's there. If it is, it'll come in straight away. So from app, if we spelt it right, well, it already doesn't find it, whereas from async.io, it would be there, or from threading, we'd find it. So this app scheduler, I'm going to rule it out, although it might have lots of useful features as well, because if somebody's made a module to do it, maybe it does a lot more than just threading or just async.io, or it behaves in a way that we might want it to in a certain way. But anyway, let's just stick with the simplistic code, which is this one. I could actually do the copy of the code. I had a version of code. I wonder if my version of code is not too much different, actually, to be fair. What I might do is I'm going to do my version of the code. Not that it's that much different, but it just highlights something, which is import threading, right? And actually, Here in our code it says from threading import timer. You could do either or. I'm going to be using this timer feature, so my version of it's just slightly different to this version. Now I need to create a function of some kind. You know, here it's got print function after 5 seconds. That's quite a nice descriptive function. 5 seconds pass. That's quite nice. You know, I do my own version of it, which is define a function, and our function, let's just call it hello. Right, we could put a doc string. We won't even put a doc string. I just sort of print hello. There we go. And all we're going to do in our function now is to print and then hello, just like this, or hello world. There we go. So we've got our print hello world. We don't even need our return here because that's kind of like the end of our function. And then we have to do, this is how we implement threading. So you know, we set our thread effectively t equals threading dot timer. We're setting our timer. That's what we're actually doing, not threading dot thread, threading dot timer. So we set our timer function, and I do this open brackets. And the reason why I wanted to do this is it's got interval float. And unlike the JavaScript version, which told us it was in milliseconds somewhere, this construction should always be called with a keyword. It tells us all of the other bits, but it doesn't tell us what the interval is, or does it anywhere? No, I don't see what the interval is, so I have to know. And if I did put in 1,000, it'd wait for 1,000 seconds, because this interval is the number of seconds. So let's just put in 3 for 3 seconds so that we don't destroy everything. And then we will run our hello function, which is just, and this is the callback actually, and that's actually what I was looking for in a way. So we do hello, and notice in JavaScript and in Python it's just the callbacks. We're just calling the function. We don't call the hello like this, because that's actually going to run the function. So we're actually calling this functions, or this callback is a pointer to like the memory address of where the function is. So that's a function, and then we would do t.start like that. And if we run our piece of code now, we're not really necessarily going to see the blocking at this point in time, but I guess we will see the blocking when we do other stuff. But just to check how our code works, the one nice thing about at least Python in Visual Studio Code is it gives us this interactive thing, and which is quite nice, because our code in our little blocks, if I do write these %++ in, it jumps out over to here and sort of like runs it on the side quite nicely in our interactive version. So I'm just going to hit the delete thing there to clear everything up and just run this little piece of code. The other thing is I know that threading works. Kind of run it, and there we go, hello world popped up 3 seconds later. Now I also just happen to know from experience that if I go back to, where is it, over there, our AI thing, that if we were using this async IO, that it wouldn't work in the interactive Python because of the way the main loop runs. But anyway, that's a side note. So again, this is more convenient. We like the threading thing. But just to show that the threading is working in the way that we thought it was working, we could do the same print statements here. Print. We could even do another print statement before the threading started, or before anything, in fact, which we can do print. This is before anything, so we know where we are in the code. You know, then effectively, you know, Python runs everything sequentially, line by line. So Python literally runs our code, and so does JavaScript, by the way. They run our code sequentially, line by line. They go through everything. It won't read the comments. It kind of like ignores the comments, but it runs our code. So it's read in our function. Then it doesn't do anything other than read the function. It knows that like the function now exists, and that if it was to be run, it will print hello world. Then it actually does a print statement, so we're expecting a print statement to come out first. Then it invokes this threading thing. Again, this threading should wait for the 3 seconds, so it should go somewhere down the end after all of our other lines of code, because all our other lines of code are going to run within that 3-second framework. Then when we do the t.start, so the function doesn't get run at t.start, it waits for 3 seconds to run. So everything in these print statements below should be run first if we've got this asynchronous behavior. So let's just do this. So we're going to do the same thing. It's print doing some work, and then again we could do print and then doing even more work. There we go, and these could be long pieces of code, but as long as they're within the 3-second piece of this threading, they will be completed before the threading. So now we can run this piece of code and see what it does. And it says this is before anything, then doing some work, then doing even more work. And if you notice, the hello world popped up at the end of it. And I imagine that if we did do something like, we could do like I guess a threading again, but this time we could do a hello, and we could make this one wait. If we made this one wait for like 3 seconds or even 4 seconds, this would invoke afterwards. Now the thing about this is this one here is only going to invoke 1 second after this one, and the reason why is everything here is run pretty damn quickly, right? This is all read and run instantaneously as it was. The delays are here, so this is going to come after 3 seconds, and this piece of code is going to be run literally. We could sort of like print a time.time and like literally see it. This is going to be line number 23 where we've invoked our threading, or 24 when we've done our t.start. I wonder if we've actually overwritten it, so I've got to be careful about that. Maybe I need a T1 and a T2. I need to be careful about that. We'll see what happens. But line number 17 and 18, where we've done our thread and we say, well, hey, wait 3 seconds to do this. And then lines number 23 and 24, we say, hey, wait 4 seconds to do that. The gap between these two periods in terms of how quickly code runs is probably going to be like a millisecond or something, like a fraction of a second. But the actual time delays are then going to be 3 seconds for this one and 4 seconds for this one. So there'll be a 1 second difference here, although there's like a millisecond difference here. So let's just get rid of all of that and go and attempt to run it. Hope we don't get an error that we're overdoing some stuff. So we get a hello world, yeah, and then we get another hello world. Now, one thing that might come into play is, let's say we don't want a hello world to be in there. How can we fit in arguments? And this, I'm now treading it doing new things, because I imagine that I would have to do something like our comment, whatever the comment is, right, which is a string. And basically here now we will print out our comment, which means that if we call this hello here and call this hello down below here, that we need some way of having arguments in there. And I presume that I'm not even 100% sure, but I might have to ask just to get it. But how do we pass in the arguments? So I just presume that we do args equals and then an iterable. So args equals, that's nice, it popped up. When it pops up, that looks nice. And iterable is this thing here, which is effectively a list, I'm imagining, and each item of the list is each argument. So I'm hoping it's that, and not a dictionary, because that would be the keyword args that goes into a dictionary. So I should just be able to put in here our hello world, and then in our next one we'll still have to do this args equals. And by the way, the setTimeout function offers in JavaScript offers us similar functionality, just invoked presumably in a different way than we're doing in Python. So I'm going to do hello moon. Hello moon. In fact, I will do good. Well, it's a hello. So yeah, hi moon. There we go. So when we run this, and the important bit really, I guess, is when we are running is to look at the times that these things do come in at. So if I hit the control return just to run it, it says this, then it says that, then it's doing even more. Then we see the hello world and we see the hello moon coming in straight after. Now we could kind of like see this because we could import time again, import time. So we could do that. we didn't like the time.sleep thing, so we don't need that bit. But what we can do is, I wonder if we can do, well, we won't be able to do the print time.now, interestingly, because unless we kind of like embedded time in there. So we could see all of the other ones when they came about, which is print time.time. So that one's this one here. We're going to get a time in this time method here. If I just go there, it's the current time in seconds since the epoch, right? Which is this number of time in seconds. I wonder if a better way of doing it is actually count the number of time in seconds that's actually elapsed. Maybe I'll do that. So we'll set a because then we can count our elapsed time. So t1 equals time.time, right? We could even start that right in the beginning of our code. So x over there. And we'll actually call it t0 for our first one. So our first time is over here. And then when this one runs, it runs at basically t1 equals time.time. And the time elapsed, we could actually put it in. Let's just put it somewhere like here. So print time elapsed. Right, and we're going to see there's basically 0 seconds. I'll round it off to a few, but round t1 minus t0. So we'll see how much time has elapsed, and we'll round it off to, let's say we'll round it off to 4 decimal places. That's enough of a fraction of a second. So we've got that one there, and then so we've got a t1 here. And in fact, I'm just going to move this up for simplicity so I can do the copy and paste. Like these little snippets, that's where this piece of code ran. This is where our implementation of the time elapsed for, and we're now going to use a T2. So each time is going to have a different version of it. Our implementation was here, which is T2. And again, we're going to count everything from T0 from our epoch time, like first time when the code started running. And then again over here we can do, this is when our work began running, and we were going to now use a T3 over here. And again we're just going to see this, and this is just to demonstrate how fast everything runs. And then finally here we've got a T4. This is really demonstrating the asynchronous behavior, so T4 minus T0. And when we run all of this now, we're going to get these time things that are effectively inserted somewhere into the code. So we've done this, and we see all straight away, right, that although these functions here took, a number of seconds to run, over here we've got time elapsed 0, then time elapsed 0.001 of a second, then 0.1 of a second, then this do work. So by the time we called our second function, there was no extra time that was consumed between T3 and T4. We see that here because that was our time elapsed here, T4. In fact, I'll draw the little arrows that point to it, but basically T4 over here, that statement there was this time elapsed here, 1.006, right? Or 0.1006, right? And our time just before it, which is this one over here, was literally the next line above it. So like literally no time ran between it. So there was, like, if you do a subtraction on your calculator, there's no time between those, but the time between these two, so the gap between these two, when it actually ran in the code, that was 1 second. And the 1 second came about because we used this timer threading.timer. We use this timer function from the threading module, and here we set 4 seconds, and on our other one, wherever it was, we set 3 seconds over there. So that was that 1 second gap. 4 minus 3 is 1 second. So that's basically it. That pretty much covers threading to, or not threading, creating asynchronous, running asynchronous times in the Python module, using one method, using one module in particular, which is a threading module. We could have achieved it using the async IO. We could have achieved it using an imported module. But we could do all of this. So we've got the same functionality in Python that we have in JavaScript, just implemented in a slightly different way. And we also show that we could like push in keyword arguments. And I guess we could do other things as well. For example, over there, I guess not only could we have printed that, but we could have actually put a time in here, funnily enough. I wonder if we did that. If we did a time elapsed in there, because I wonder what time elapsed would come out, because we'd have to set a t inside of here. Now notice that this t is different from this t. I'm allowed to do that. The reason that this t is different from this t is because it's encapsulated, it's enclosed, so it's at a different scope than this t. So I can use the same t's if I like, so long as I understand scoping in Python, or in what you might call encapsulation. It's closed inside the scope, so scoping. But I can do time here, and then that will be that time there. And what we could do is print, I guess, the actual seconds rather than doing sort of like the countdown thing. But we could sort of like, I think we could actually print out t over there. That would sort of like print it out. And if we ran this code, we would get when the first one was done and the second one. And I think that because the threadings are going to happen at the same time, they're going to be pretty instantaneous. So we're going to get 2 epoch times, I think. Let's just have a look and see. Or do we? Let's have a look. We've got the 160914. Yeah, here is the 1 second gap. So this t here is only invoked or only run called after 4 seconds, and we literally see that 1 second gap, because that's all of the other stuff. If I can do the highlighting like this, I think. But all of this is exactly the same up to this point, and all of this is exactly the same up to this point. And then the 19 over here is that it ran at like second number 19, and this is 1 second later, ignoring the fractional parts of the second. So, in fact, I can force it to ignore the fractional parts of the second, because we can just, I imagine, just do int of t there, and hopefully now we'll see the gap which will come about. That's 8.4 and that's 8.5, so that last piece there. And if we were to extend this, so instead of waiting 4 seconds, let's go to our code now and have a look. This one waited for 3 seconds over here. Let's make this one, instead of waiting for 4 seconds, let it wait for 5. Let it wait for 6 seconds, or like 8 seconds there. So we've got a 5 second gap in between the two. We can run this code again, and we should see the difference between those epoch times. This is 1.5, so I'm imagining that the other one will be 20 or close to it. And there we go, it's 20. So we see how the asynchronous functions work in Python. They're called at that point in time, because we could observe that by the time.time. And they run, so it's literally reserved for a certain point in time, and then it goes and actually runs that function as if it literally went in the code. And we know that everything's run sequentially, but literally over at, where is it, this point here, it's saying, hey, go back here and run it in 3 seconds time. And here it's saying, hey, go back and run this one in 8 seconds time. So it's like, let's run it in 3 seconds, 8 seconds. So they're putting these things somewhere into like a theoretical event loop in the same way, like wait that period of time and then run it. So that's really it. That's that's creating asynchronous times in Python using the import thread, the threading module, and using the timer function from the timer method from the threading module. So that's it. If you have any comments, leave your comments. If If you like this, if it was helpful, click the like button, follow, like, comments, all the rest of it. And that's it. Threading, times, and asynchronous.